So today it's going to be a day about assemblies and what is an assembly and why do we have them. Whenever you've got more than one part, you want to sort of keep them as a collection together, which we call an assembly. In this particular case, we're going to take a similar PG71 bracket to what was made up the other day, but we're going to use parts step files from MECH, the supplier, directly. Rather than having to recreate these brackets, we can just drag and drop and import them. The files that we're going to be using are from the MECH website up here. Do a search for PG71, I think it was AM2917 is the part number, and we go to downloads and we choose the PG71 with the encoder, but it won't really matter because the process will remain the same for whatever parts that you're actually going to want to assemble together. Download this, put it somewhere that you can so that you can find it easily, and do the same with the 2197 bracket, also from MECH here, under downloads, and then grab the step file. It'll either be STP or STEP, and yeah, grab them, put them somewhere that Fusion can access them, and open up Fusion, go into a project folder. So on the left-hand side here, you can create folders, and they're a nice way of organizing your projects. I keep most of the YouTube stuff inside of this YouTube Fusion 360 tutorials project. And to upload the part, we just click on the cloud. Oh, if you can't see the data window, let's say your screen looks like this, you can show the data panel just by clicking on this little grid icon here, and it pulls that up for you. So let's upload the pictures by clicking, the step files by clicking upload, and we can either go in here and choose select files, or we can drag and drop the files there like that, press upload, and let it do its thing. And this might take a little while depending on how quick your internet connection is. For me, it sort of takes like about a minute or so. So let's just sit here and let it chooch. So we've got two items complete here now. Hit close, and we've got, so the preview isn't showing for them. Oh, there it goes. So we've got the motor and we've got the bracket. Let's drag and drop the bracket. Well, we've got to save it before importing. So, assembly tutorial. Drag that in. Yep. And so now that we're working with a part inside of an assembly, we can move that part around. And when we first drag and drop the part in, it shows us the move box, because let's pretend we're assembling a car and we want to put the tire on, or we want to put the wheel on, sorry. Chances are you don't want the wheel to just you do want it to magically appear in the right spot, but chances are it won't. So you've got to drag and move that wheel around. And in this particular case, we'll want to drag the bracket around a little bit so that it's facing the right way for us. And one of the things that I like to do is if something's not going to be a moving part, I like to ground it. And what that means is it just means we're going to fix it in space so that it can't move. So that's grounded, and this is what is going to be like our reference point. Let's drag and drop the motor in. And like I said, it won't magically appear in the right direction, so let's just swing this around 90 degrees. And this hole here wants to align with this hole here. And this locating feature here, the arc, we want it to align with this ring here. And it looks like the encoder sort of got disconnected from the rest of the motor, so let's just hide the encoder because that's not really necessary. We'll reattach it again later as a part of assemblies. So assemblies are basically a series of things that are joined together, and a joint can be found up here in the assembly menu under joint, and we just want to push that. When it says some components have moved, yeah, we moved the motor so we could see roughly where it's going to go. We can either hit continue and it'll move the motor back to where it was originally, or capture position, and that'll hold it there while we set up the joint. And joints they take a lot of playing around with because there's just so many different ways you can join things together. What we probably want to do is join this face, which is that curvy one, with this face here. But what you might have noticed is that we get these little rings, almost like an old-fashioned focus ring on a Nikon camera. We get them up here, and it's, while we can select the face, how far along this face is it that we're actually wanting the joint to take place? I'm thinking this back edge corner here, we can sort of see. It's hard to show without moving the mouse cursor, but we can see that there are a couple of little white dots, and then there's that focus ring thing. And depending on whereabouts we put the mouse cursor, we can set it either to the front, to the back, and also into the middle. I'm going to set it towards the back, and we're going to put the other one here on the back there, like that. And so the reason why I chose the back is because I want the back of this face here to be mated against the front face of the motor. We've got a couple of different types of motion that we can also set for the for the joint. Because we don't want this one to move, we're going to say it's a rigid joint. We'll hit OK. Now let's also make sure that the holes are lined up. So that's one of the screw holes. Let's push J for joint. I will choose the front of that screw hole to mate with the back. Oh, it's already constrained because all these two parts are already constrained. So we don't actually need to do that. And that's what that little pop-up was, saying you've already got something here. And that's how we do sort of a simple assembly in Fusion. Let's go and attach that Hall effect sensor now because, well, we dragged it out of the way and we probably do want it attached. So I'm not too familiar with how the Hall effect sensor actually attaches to the back here. It may be that there's no tabs, there's no screw holes. Alright, let's just pretend it's glued on so that there's some glue on the back face, and it would glue to maybe what would it face against? because there's no real geometry there for it to mate up against. Okay, let's go with a motion joint. Because this shaft spins around either clockwise or counterclockwise, what we can do is we can say we want this shaft, and let's choose this back edge here. That shaft is going to be a revolute joint, meaning it revolves. And we're going to say it's going to revolve around this edge here. And oddly enough, it's made the entire motor revolve rather than just the shaft. One of the neat things we can do is we can hit animate, and it spins that around for us. But there we go. And in this particular case, it's going to be the encoder that spins, because we've got the bracket here that's grounded, and so the bracket's not going to move. And then the motor here is constrained rigidly to the brackets, so the motor's not going to move either. But we have this revolute joint here, and that's the only motion that's permitted, so the encoder is just going to be allowed to free spin around. In actual fact, it would be the shaft that would be a separate part inside of the motor here that we would then be able to say that will revolve. But because we haven't delved into the PG-71 model, we aren't going to be able to get it to revolve just yet. And that might be something worth playing around with as homework to see if you can get this to revolve independently of the motor. Until then, have fun.